This video will cover measuring angles using a protractor when two angles are labeled as congruent, when we are adding together two parts of an angle, and when there's an angle bisector. Similar to segments where the two segments were congruent and the lengths were equal, with angles we use the equal sign with the squiggly above it to say that angle A is congruent to angle B, but the measure of angle A is going to be equal to angle B. Here are the steps how to measure an angle with a protractor. The first thing you do is you place the midpoint of the protractor on the vertex of the angle. So that would be here, here, and there. Then we're going to line up one side of the angle with the zero line of the protractor. So here's one side of an angle lined up with 0, one side lined up with 0, and one side lined up with 0. Finally, we read the degrees where the other side crosses the number scale. So here we are on the less than 90 side, since this is an acute angle. So something like 72 degrees would be the measure of this angle. It would be considered acute. The second angle is an obtuse angle, since it's above 90 degrees. So we don't look at the bottom here, we look at the top, and it measures 100 degrees. Our third angle is also obtuse, meaning we're not looking at the 10, we're looking at the 170, and it looks like it might be 172, which is also classified as obtuse. Angle addition postulate. If P is in the interior of angle RST, then... So first, let's draw the vertex. It's going to be the middle letter here, S, and my two sides are going to be R and T. So I just put the R on the bottom, I could have done it vice versa, and I labeled these points on those sides of the angle. Since P is somewhere here in the interior, if I was to draw out a ray, we're pretty much saying that this angle here added to that second angle is equal to the whole, just like we did with line segments. I might write out this postulate as angle PST plus angle PSR is equal to angle RST. So in this example, if I wanted to find out what ABC was, all I have to do is add together 90 and 45, and it's 135 degrees, which is obtuse. The 90 degree angle is a right angle, and the 45 degree angle is acute, which I could write this way: angle ABC is equal to 135 degrees. An angle bisector is a ray that divides an angle into two congruent angles, and we indicate that congruency with these little hash marks, that those two angles are equal. So for example, if this was 60 degrees, then this one would also be 60 degrees. So in example 3, because Km bisects JKL, 4x plus 6 is equal to 7x minus 12. So we can set up our equation like this. We can subtract 4x from both sides, add 12 to both sides, and this tells me after I divide that x is equal to 6. They don't want to know what x is though, they want to know the measure of angle JKM. So that means I'm going to be substituting 6 in over here. 4 times 6 plus 6. And that's going to be 30 degrees for angle JKM. In part B, it would be tempting to try to set these two equal to each other again, since we're looking at an angle bisector after all. But if you were to draw the diagram and follow which angles they're referring to, PQS is 1/2 5y minus 1, but PQR is the entire thing. So it turns out that whatever this angle is times 2 is equal to the whole part. So it's almost like I can label this other angle 5y minus 1 also, since they are congruent, because QS bisects it. So you could write this by adding those two together, or you could think of it as doubling that one angle. Both will give you the same result. So let's go ahead and distribute the 2 here. This becomes 10y minus 2 is equal to 8y plus 12. I can subtract 8y from both sides, add 2 to both sides, and then divide by 2 to get that y is equal to 7. And they want us to find PQS. So that tells me I can substitute in here, and this becomes 5 times 7 minus 1. So angle PQS is equal to 34 degrees. This example C, we go back to the other type of problem, where these two are equal to each other. So I set up my equation like this. If I add 10x to both sides, I get this. I might subtract 21 from both sides. 9x is equal to negative 18, or x is equal to negative 2. They want us to find LJM, so I'm going to plug that back in where? Well, that's the whole angle, LJM. So I could just take either one of these, plug it in, and then double it. That'd probably be the fastest step. I could plug it into both and add it all together, but we know that this angle is equal to that because JK bisects it. So I'll plug it in once, give myself a negative 2 plus 21, so 23 degrees, and then I'll double that. And my answer is 46 degrees. So don't be fooled by the size of your sample diagram. Mine didn't happen to be 46 degrees, but that's the answer anyway. I was just making up an angle. The size didn't matter.